This is lesson 11-6, and today we're going to talk about proportional segments between parallel lines. So if you look at the triangle below, we have AB, which is parallel to side CD, which is the bottom side of the triangle there. So there's AB, and it's parallel to the bottom here, which is segment CD. So before, if we were going to talk about comparing segments XA and XC, we would have to talk about triangles. So we would have to talk about this whole triangle here, and let me just pull that off to the side. And then we'd have to talk about the larger triangle, like this. Oops, my drawing's not so good, but it's okay. And pull that off to the side. So we'd have to compare the left-hand side of the small triangle with the side of the larger triangle. Because the two triangles are similar because of AA, I'm marking those angles right there. And so we wonder if there's a shortcut, it's between that segment, and on the right hand side that segment and that segment. Rather than comparing triangles, can I just compare these two segments with these two segments over here? And the answer to that question is yes, you can. You do not have to draw out the triangles. Let's look at an example. Here we have EO is parallel to side LN. So here we have those parallel lines right here and here. And then we'll talk about the segments that are in between. So Y, that segment right there, and how it compares to NO over here, which is 36. So let's set up a proportion. 36 is to 48, just like segment Y relates to EM, which is 60. So we have a nice proportion there, which does work. And I'm going to go ahead and cross multiply. And 36 times 60 is 2,160. 48 times Y is 48Y. And next to my equation solving, I'm going to divide both sides by 48. And Y equals 2160 divided by 48 is 45. Yeah, so that's a nice shortcut. And rather than working with two triangles, you can work with those segments. Let's try a third example. This one's different because you have not one, two, but three parallel segments to compare. And so we wonder if the same rule applies between all three sets of segments. Are they proportional? And the answer is yes. And so let's set up some proportions and solve and figure out what X and Y, what those lengths are. So I can say 21 relates to 42, just like 35 relates to X. So 21 times X is 21X, and then 42 times 35 is 1,470. I'm going to divide both sides by 21, and X is equal to 70. So I found out that X is 70. So let's see if we can figure out what the other segment is. What Y would be. So I can use 70 or I can use 42, either segment there in my proportion. I'm going to stick with the original one. So 21 relates to 42, just like 28, segment LG, relates to Y, which is segment AR, 28 over Y. So let's go ahead and cross multiply. 21 over, times Y is 21Y. 42 times 28 is 1,176. I'm going to divide both sides by 21. And Y, let me use my calculator here, Y equals 56. So there you have it. It works with more than one parallel line. So let's talk about the big idea here today. The big idea is that you don't just have to rely on triangles. When you have parallel lines intersecting other lines, like in this case we use a triangle, those segments that I'm marking, they're not congruent, they're proportional. And that proportion remains the same throughout the entire, for all those segments there.